See, the third unit topic is variable resistance transducers. So in this variable resistance, the resistance values can be adjustable in different kind of variable resistance in transducers are there. So in that, we are seeing principles of operations of variable resistance transducer, how to construct or how to configure variable resistance transducer, and what are the characteristics and applications of variable resistance transducer. So the principle, construction, and the characteristics of different variable resistance transducers are configured. So in that, first example is potentiometer and strain gauge, or resistance thermometer, thermistor, and a hot wire anemometer, piezoresistive sensor, and humidity sensor. So these are all the devices are working based on variable resistance. Okay. So now first we see the topic is first we know the transducer. So the transducer is a device. It converts the energy from one form to another form, physical form into electrical form. We know. Okay, so this electrical transducer specifically is a device. It converts physical quantity or a physical condition into an electrical signal. Some physical form kind of signal is converted into electrical signal. So the another name for this electrical transducer is called as pickup. Okay. So advantages of this electrical transducer is there are number of transducers which transforms a variety of physical quantities into electrical signal. For example, our weight is converted into electrical signal. Weight means mass. Okay. Otherwise, the speed is converted into electrical signal. So this different kind of physical quantities are converted into electrical signal, which is done by electrical transducers. Okay. So what is the advantages of converting physical quantity into electrical quantity? So first thing, we are saving electrical power. Okay. So the electrical amplification and attenuation can be done easily. That too very much with the help of static devices. One is the mass inertia effect are minimized based on the weight, mass or inertia. I mean, the mechanical translational system means the weight is called as mass. Otherwise, the mechanical rotational system means the weight is called as inertia, moment of inertia, which is expressed by letter J. At the same time, the mechanical translation system means the weight is expressed by mass, M. Okay. So for that systems, we are giving external force. For mechanical translation system means we are giving the force is expressed by the letter F. Okay, capital F. For mechanical rotational systems, we are giving the external force is J. Sorry, torque. Angular force, torque. Okay. So then, for converting these physical quantities into electrical quantities, one thing, mass inertia effect are minimized. And second one, effect of friction are minimized. Okay. Then these electrical or electronic systems can be controlled with a very small power level. So automatically the system can be controlled with the help of this kind of power. And the electrical output can be easily used, and we can transmit easily and processed for the purpose of measurement. So these are all the advantages of converting physical quantities into electrical quantity. And the next thing, generally we know the transducers are classified into on the basis of principle of transduction, otherwise primary and secondary transducers, and another way active and passive transducers, and another one analog and digital transducers, and in generally transducer and inverse transducers. Okay, so here in a passive transducers means the transducer is not in active, so we need to give the power externally. Okay, for passive transducers, we need to give the power externally. So, for example, one is resistance. Okay, in that resistance transducers are examples: potentiometer device, resistance strain gauge, hot wire meter, resistance thermometer, thermometer resistance or hydrometer, and photoconductive cell. Okay, so these are all the examples of resistance. I mean, one of the passive transducer. Okay, and based on the capacitance. Okay, that transducers are examples of the transducers are one is variable capacitance pressure gauge and capacitor microphone, and dielectric gauge. Okay, so with respect to inductance, the devices are magnetic circuit transducer, reluctance pickup, differential transformer, eddy current gauge, and magnetostricance gauge. Okay, and how to convert the physical form into voltage or current. So for that, examples are Hall effect pickup, ionization chamber, and photoemissive cell, and photo multiplier tube. Okay, so these are the examples for converting the physical quantity into voltage or current. And self-generating transducers. So for this kind of transducers, we need not to give the power externally. So no external power. External power is not needed. Okay. So example for self-generating transducers are thermocouple and thermophile, moving coil generator, piezoelectric pickup, and photovoltaic. So these are all the devices convert the signal, physical signal into electrical signal without any external power. Okay. Then resistive transducers. So resistive transducer means it's an electronic device. It is capable of measuring the physical quantity like temperature or pressure or vibration or force. So these kind of physical quantities are measured by this resistive transducer. Okay. So using these resistive transducers, we can easily calculate the values like temperature or pressure or vibration or force, etc., etc. Okay. So these transducers, the resistance of these transducers changes concerning the change in physical quantities. Okay. So resistance transducers means in that transducer, if the resistance values are changed, means the resistance transducers measuring the physical quantities. So the values or measurement is varying in the physical quantities also. Okay, so this is the concept of resistance transducer. In a capacitive transducer means if a capacitance values affect the measurement. Okay, inductance values in inductive transducers, inductance values is affect the measurement. So likewise. Okay, so in a resistive transducers, so resistance of these transducers changes. So concerning changes occur in the physical quantities. I mean, while measuring temperature or pressure, vibration, force. So these kind of values are also varying. If varying in a resistance. Okay. So these transducers can function in both the primary as well as secondary mode, but most of the time it is used as secondary mode because the output of the primary transducer can be given as an input to the secondary transducer for I mean which one for resisting transducers. Okay, so the primary transducers mainly used in the conversion of physical quantities into mechanical signal, while the secondary transducers are used to convert the physical quantities into electrical signal directly without first conversion. Without first conversion, the secondary transducers directly convert the physical quantities into electrical signal. Okay. So the physical quantity means we know the temperature, pressure, vibration, force. Okay. Non-electrical form. Non-electrical form is directly converted into electrical form. Okay. So the resistive transducers are different types like resistive pressure transducer or thermistor or resistors or the LDR. So these are all the example of resistive pressure transducers. Okay. Then see the working of resistive transducers actually by considering the conductor rod in the transducer. Okay. See the transducer majorly works based on the principles of the length of the transducer. So in a metal rod or metal conductor, the resistance value is expressed by rho L divided by A. So here, if the resistance is varying means while measuring the physical quantities, values also vary. So in a metal rod, the rod length or the conductor length of the conductor is expressed by letter L. It is denoted the unit in terms of meter. And A is the cross-sectional area of the conductor or metal rod in terms of meter square. And rho is the resistivity of the conductor, ohm meter. Okay. So based on these parameters, the resistance values of the conductor is measured. Okay. So R is equal to rho L by A. Then one major example of resistance transducer is potentiometer. So basically the resistance potentiometer, which is simply expressed as POT, resistance potentiometer. It is used for the purpose of voltage division. Okay, it is called as POT. It consists of a resistive element provided with a sliding contact. The sliding contact is called as wiper. Okay. So the motion of the sliding contact may be either translational or rotational. See, we know the translational is nothing but we are giving the external force F, and the mass or weight of the system is expressed by M, and the displacement is in terms of either horizontal or vertical, X or Y. In the rotational means we are giving the external force is torque, and the system is rotated. The displacement is the angular displacement in terms of theta, and the weight of the system is expressed by inertia, moment of inertia. Okay. So some potentiometers use the combination of two motions, one is translational as well as rotational. And these kind of potentiometers have a resistive element in the form of helix. Helix means it's a coil is formed by winding wire around a uniform tube. Okay, so that is called as heliport. Then the translational resistive element are straight device and have a stroke of 2 mm. The thickness is 2 mm to 0.5 mm. 0.2 mm to 0.5 meter. Okay. Then the rotational devices are circular in shape and used for the measurement of the angular displacement. If not in circular means the displacement is just X or Y direction, either horizontal or vertical. Okay. So this is the linear translational potentiometer. I mean, due to that force, it is shifted either in horizontal direction or in vertical direction. So that is a translational potentiometer. Okay. And the rotational potentiometer. So here, due to the external force, so this is, I mean, the system is moved either in rotational, either in forward or reverse direction. So with respect to angle. Okay. And the resistive body of the potentiometers is nothing but maybe wire wound on a insulated former. So the potentiometer is a passive transducer since it requires an external power source for its operations. Okay. So this is major thing. And so the characteristics of potentiometers, we considering some kind of parameters EI and E naught. That is input and output voltages, and X of is the total length of the translational potentiometer. X of is I is the displacement of the wiper, and R of is the total resistance of the potentiometer. So using those parameters, the output voltage under the ideal conditions of the potentiometer is measured by resistance at the output terminal by resistance at the input terminals into input voltage. Okay, so this is the formula for measuring the output voltage. Okay, so this is under ideal circumstances, the output voltage varies linearly with respect to displacement. Okay, if a displacement is varying, so the output voltage is also varying in a linear manner. Okay, so from this, the sensitivity is analyzed by output by input. Okay. And in a angular displacement, the output voltage E naught is equal to EI into theta I by theta T. So EI is the input voltage and theta I is the input angular displacement in degree, and theta T is the total travel of the wiper in the degree. In terms of degree, angle we are measuring the displacement is called angular displacement. Okay. And power rating of measurements. So in that power rating, so the potentiometers are designed with a definite power rating, which is related directly to their heat dissipating capacity. Okay, so here the range from, actually the resistivity range from 100 ohm to 10 kilo ohm in steps of 100 ohm, where, so the manufacturer normally design a series of potentiometer in a single turn with a diameter of 50 mm with a wide range of ohmic value. So for that the range is 100 ohm to 10 kilo ohm in steps of 100 ohm. Okay. So normally the rating is of that potentiometer is typically 5 watts at an ambient temperature of 21 degrees Celsius. Okay. So generally the power is equal to input voltage square by R sub is P. R sub is P is the major parameter for which one total resistance of the potentiometer. Okay. So maximum input excitation voltage can be measured by square root of P into RP in terms of voltage. Okay. And constructions of potentiometers. So full and full it is a wire wounding, single wire of conducting material which gives a continuous step less variation of resistance as the wiper. Okay. Then full and full the potentiometer resolution is dependent upon the constructions of the resistive element. Okay, so the resistive wire is wound on a mandrel or a cord for translational displacement. And the major advantages and disadvantages of resistance potentiometer. Advantages are it is a very useful for measuring the large amplitude of displacement, and this electrical efficiency is very high, and it provides sufficient output to permit control operations without further amplification. Okay, so the disadvantages of a resistance potentiometer is main thing, the linear potentiometers, they require large force to move their sliding contact. So this is major disadvantage. Okay, large force is needed. The other problem with the sliding contact is they can be contaminated, can wear out and becoming misaligned and generate noise. So the life of the transducer is limited. Okay, so this is the major disadvantage. Okay, so the resistance potentiometer, the major example is resistance transducer, major example is potentiometer. Here, based on the resistance variations, so the this effect is occur while measurement. Okay, thank you.